Hello, this is Beth Dixon, and today I'm going to be looking at some simplifying expressions. And we're going to start with some definitions, the first of which I've already written down here, numerical coefficients. A numerical coefficient, think of the first word, numerical, meaning number, and the coefficient meaning is a mathematical term meaning a factor of, and generally that means the number part. And so the best way to look at the numerical coefficient is to look at some examples. For example, in the term 5y, the numerical coefficient of this is the 5. It's the number part of this expression, of this term. And now I've just used two other definitions that we then need to define. The first of one that I used was the term expression. Now, an expression is a group of algebra and variables and numbers that are joined together with pluses and minuses. So an expression, for example, are things like 3x plus 2y, 4x squared minus 6, I said 6, but I wrote 2, minus 2xy minus 4y squared. Those are expressions. Now, an expression is made up of terms. The terms are the parts of the expression, the things that are separated by the plus signs or the minus signs. So this whole thing here is the expression, and 3x and 2y are the terms. For this one right here, 4x squared, negative 2xy, and negative 4y squared are the terms. Now notice the little trick here with the sign. It's not a trick, because what we're really thinking here is that we can think of this as well as a subtract. We can think of this as plus a negative 2xy and plus a negative 4y squared. So that sign has to stay with that term. And so even though we'll not write it this way, that's too cumbersome and too much signs going on, that's the way we think of it. We think of this subtract as making this term a negative, because it's the same as adding a negative. Therefore, that second term becomes a negative. It's my duck theory. If it looks like a duck and quacks like a duck, it's a duck. That looks like a negative. It acts like a negative. Therefore, it is a negative. Do we need to go through this process? No, we can just look at it. So that's an expression and a term. Well, what's the difference between an expression, and as we get into the next chapter, we'll be looking at equations? Well, these are expressions. When I put this little symbol here, and I really should have put that little symbol there just to say that I'm making it change into this, it's equivalent to. But when I make it an equation, if I go like 2x minus 3 and then I put equals 4, that's an equation because it has an equal sign. Notice when I first wrote these, they did not have equals. Therefore, they're expressions. If it has an equal sign, it's an equation. So that's the difference between an expression and an equation. So if I write 2x squared minus 3, that's an expression. If I write 4y minus 2 equals 5, that's an equation. This is an expression. This is an equation. If I write 2x squared equals 3, that's an equation. Now, once we have terms, we then want to kind of classify terms. Terms come in two types. They're either like or unlike. If I have 3x and 2y, these are unlike terms because the x and the y are different. If I have 2x and 3x, these are like terms because the x parts are the same. Notice that it's not the numerical coefficient that has to be the same, but the variable part. So to be a like term, you have to have identical variable parts. The numbers can be different, but the variables have to be the same. Identical variable parts. Now, let's look at 2x squared and 2x. Are they like or unlike? Well, they're unlike because they're not the same. Even though the variable is the same letter, the parts are different because one's squared and one is not. So they are unlike terms. That leaves us one last definition. I'm going to flip over my page here. One last definition, and that is the distributive property. And the word distributive. Distributive property is the one property our students are struggling with the most. And distributive is a multiplication over an addition or a subtraction. Okay? Distributive property does not apply to a problem that has just multiplication. It does not apply to problems with just addition and subtraction. It's a combination of the two. In basic, it says, if you look it up in the book, it'll put an A, and then it'll put a B, and a C, and then it'll put an equal, and it'll say AB plus AC. That's the way it's presented. All it's saying is that if I have a number out front, say a 4, and I have two numbers inside, say a 3 and a 5, that I can do this problem one of two ways. I can say 4 times 8 and get 32, or I can say 4 times 3 and get 12, plus 4 times 5 and get 20, and add 12 plus 20 and get 32. Well, in this problem, this is the obvious winner. That's much easier to do than the second way. However, if I have 4 times x plus 5, I cannot add the x and the 5 because they are not like terms. And we'll talk more about that in the next video, about when we add like terms and when we can't add like terms. But I can't combine those two together. So we have 4, and if I want to simplify this in any way, I have to do it the second way, which is to multiply the 4 times the first term. Well, the 4 times x is just 4x. And 4 times 5 which is 20. And then we'll consider this a little bit more simple than this, because this can then be added and combined with other terms. And I said that was the last term, but I did forget one other expression, and that's the combine like terms. Kind of went a little bit out of order, but that's okay. We're not being in a lecture form. We're just kind of going over some terms. And in this case, combine like terms. Well, if we have 2x plus 3x like we had before, these are like terms. And it's saying I have 2 of them and then I have 3 of them. And if I use this distributive property, and I could go into the whys, but in my videos I'm not into the whys. Your teacher can give you the lecture and the showing you the how. I'm going to show you the whys. I'm going to show you the hows. And the hows of this one is that we're simply going to add the numerical parts. Remember, we talked about the numerical coefficients. That's this part right here and this part right there. And we're going to say 2 plus 3, and 2 plus 3 gives me 5, and then we keep the x, and that's combining the like terms. When we add or subtract, as the case may be, that will be combining our like terms. So this is going to end our first video, and this is some of the definitions needed to simplify expressions.